Okay, so till now we have seen the problems on concurrent force system, where the concurrent force system is when all the forces meet at a one particular point. In that we have solved all the problems, including the Lami's theorem problem. So Lami's theorem is also applicable to on concurrent forces. Now the type number two comes is the problems on the parallel force system. Type number two, parallel forces. Now as the word indicate, parallel forces means all the forces are exactly parallel to each other. They never meet at a one particular point. Hence it is termed as a parallel forces. So while solving the problems on parallel forces, there are some important terms that we have to first see. First one is the moment of the force, because while calculating the resultant for parallel forces or couple for the parallel forces, we need to find out the moment of the force. So moment of the force is nothing but it is a definition of the tendency of the force to produce the rotation about a point. So moment of the force is nothing but that particular force has a tendency to produce the rotation about the point, and hence it is termed as the moment of the force. For example, if the force is acting on a particular beam at a certain distance, then that particular force will try to have the rotation about that particular beam. So that's why it is termed as moment of the force. And the moment of the force can be calculated by the product of the magnitude of the force and the perpendicular distance at a particular point. For example, the magnitude of the force means that magnitude multiplied by the perpendicular distance from a point. For example, here you can see simple example, there is a beam AB, there is a beam AB at point O. The force W is acting at point A, the force F is acting at point B, and if I want to find out the moment at point O, so moment means the force has a tendency to produce the rotation, and that magnitude can be calculated as product of that particular force into perpendicular distance from the point or considered point. For example, if I want to find out the moment at point O, so the moment of W at point O can be written as mw, capital M suffix W, that is moment of force W is equals to the product of the force into product of the force and the perpendicular distance from that particular point. So this W into D1 will be moment of force W. So mw is equals to the magnitude of force W and the perpendicular distance from point O, so W into D1. Similarly, if I want to know the moment of force F at point O, so F about at point O will be written as moment of force F, or simply capital M, that is for moment, is equals to the product of force and perpendicular distance, so F into D2. F into D2. Important is, in simple sentence, the moment is nothing but the product of magnitude of force and the perpendicular distance from a point. Okay, now here while calculating the moment or while adding the while solving the problem, we need to come across the sign convention. Now here we'll consider, from here while solving the problems on parallel force system or any other force system, we'll consider the moment sign convention. Anti-clockwise will be considered as a negative and clockwise will be considered as a positive. If the moment is clockwise, will be considered as a positive. If the moment is anti-clockwise, will be considered as a negative.